We just went over the answers to the practice test. All right, now give me some numbers that you're not really sure about. Maybe you got them wrong. Didn't understand them. 7. Which ones? Give me numbers. 11, 12, and okay. Let's say 10 to 13. We'll do that whole group of them. Okay. What else on here? Is there anything else that was causing you trouble?
That's about it.
What about the centroid stuff? 2, 3, and 4. Did you get that?
No. Oh wait, is that the one where it's like divide that one number by 3?
Yes.
Alright.
You okay with that? All right. Well, let's do these, and we'll see if we have any more to do after this. All right, you guys paying attention? All right, let's do number 7 first. Let me draw this thing out. Remember, you're taking a test tomorrow. It doesn't seem like some of you actually believe we're going to take a test tomorrow, but we are. And don't think that you'll just pray for snow and you won't have the test tomorrow, because it's not supposed to start snowing until after school's out tomorrow anyway. So don't rely on that. Be prepared for your test. All right. I think it's supposed to snow enough if we have enough to cancel school, but probably Wednesday. I don't know. How do I know how much we're going to get? I did hear 6 inches, something like that. I don't know if I heard 6 to 10, but I mean, I did hear. I mean, if we get 6 inches, they'll definitely cancel school, I would think. Wait a minute, I'm doing this wrong. You've got me. You guys got me all messed up. I don't know. Watch. What if we did this? You guys watching? This thing comes and it hits at a right angle, and it comes right here and it hits at a right angle. So that's 90 degrees. That's 90 degrees. This is W. This is X. I sure hope you guys are laughing and smiling so much after the test tomorrow. Okay? I hope you're that happy that you've done well. Because I just have a feeling that that's not going to be the case, and you guys are just playing around as we're trying to go through this. Watch, this is 3x plus 5, and this is 5x minus 7. Okay, watch very carefully. Here's the deal, watch. It says that these two angles right here are equal to each other. Well, look what we have. Look at this triangle and look at this triangle right here. I mean, you can even forget the theorems and all that kind of stuff. Well, forget the particular theorem about this. But it does say, we do have a theorem that says this. If a point lies on the angle bisector, it's equidistant from the two sides of the angle. Right? If you didn't remember that, you could look at what's the information given. Look, I've got an angle and an angle, right? That's one angle. I've got two angles, and I've got a side. So I've got angle, angle, side. What's true about these two triangles right here? They're not equal. We don't say equal. What do we say? We say they're congruent to each other. So if they're congruent to each other, then that means what? 3x plus 5, this side right here, is equal to what? This side right here. Do you see that? So if these triangles are congruent to each other, these two sides are equal. Or, again, I'll say it again. Our theorem says this. If we have a point that lies on the angle bisector, it's equidistant from the sides of the angle. Do you hear what I just said? It's equidistant. It's the same distance to this side as it is to this side. That means these two are equal to each other. So, what do? We set them equal to each other, and then we solve for x. Now the question on number 7 says find what the length of xz is equal to. All right? That's what we're trying to find right there, xz. So first of all, we set these equal to each other and we solve for x. Is that going to be our final answer though? No. What do we have to do once we solve for x? Plug it in, right. Plug it back in and find this length right here. Everybody get that? So let's do this. Subtract 3x from both sides and I get 2x. Add a 2 to both sides and I get, what did I do? I didn't write this. 3x plus 7, 5x. Oh, it's 5x minus 7, not 5x minus 2. I was wondering, because I knew this came out even, and that wouldn't come out even. So it's 5x minus 7. Let's try this one more time. So I still subtracted 3x from both sides, but what do I do now? I add a 7 to this. What do I get? 12. Divide by 2. What's x? It's 6. Is that my answer? Do I circle it? No. Okay, make sure that you read the instructions very carefully. I told my other class this, and I'll tell you this. I had a girl in my honors class the other day. She has not missed one question on a quiz or a test all year. Okay, she has not missed one question. Every homework she's got a 5 out of 5. Every quiz she either got a 10 out of 10 or a 20 out of 20. Every test she got a. Listen to me. Would you guys listen to me? You're being rude. Just listen to me. Didn't say her name. If I wanted you to know her name, I would have said who she was. Okay, so she got 100 on every single test we've taken so far. She missed her first problem the other day. You know what she forgot to do? She did this and circled it. Now, it wasn't this exact same problem, but it was something similar to it. And she forgot to do what? Plug it back in. Okay. Now, she knows that. All right. And she'll probably look at it today and say, oh, I can't believe I did that. Because she knows what to do. She just forgot. So that just goes to show you, if somebody that's never missed a problem all year can forget to do that, think of how easy for us it would be to do that. So this is just a reminder for you. Okay, it's just a reminder to make sure that you realize what you're trying to solve for. You're trying to solve for xz. So what do? It's 3x plus 5, right? That's what this length is. So what do? We put a 6 in for that. So what do we get? Oh, that's a plus, not equals. So what's that? 18 plus 5 is 23. So xz is 23. Just like that. Make sense? Okay. I spent too much time on that. Let's go to this other little section right here. Let's go 10 to 13. Let me pause this while I draw a picture because it takes a little while to draw the picture. There's a chart on page 337 that gives you all these different these points, these special segments and points. Circumcenter, incenter, centroid, orthocenter. And it tells you how to find each one of those things. So this problem right here on 10 to 13 says we're going to find the incenter. Look at that chart for incenter. What do we have to do to these either sides or angles in order to find the incenter? Look at the chart, page 337. Look at incenter. What do we have to draw on this triangle? The angle bisector. That's right. So what I'm going to do is I'm going to draw an angle bisector. So what does that mean? Does that mean we come down here and hit the middle of the other side? No, that's not an angle bisector. That's the median. We're trying to find the angle bisector. I'm taking this angle right here. Do you see it, how it's swinging around? What I want to do is I want to make it so that it splits it in half. Does that look like it splits that angle in half? Does that look like it splits the angle in half? No. Probably around in here somewhere. Is that pretty close? That's good enough. Okay, watch. Then take this angle and do the same thing, angle bisector. Again, I'm taking this angle and I'm splitting it into half. I'd say about right in there somewhere. That's pretty close.
Don't you have to extend it to the right?
You don't have to because I'm going to show you why. Watch this. Now this one, if I do the angle bisector, it should hit right at that intersection, okay? Now watch. When they draw this in the book, they don't extend that line. That's why I didn't. So they just take it to the point. They take this one just to the point, and this one to that point. Everybody see that? So that right there is the incenter. Go back to that. Go back to that chart. That incenter. Remember, we got something we know about it. What is it? Is it equidistant from the vertices? Is it 2/3? 1/3, is it that one?
No.
No. It's what? It's equidistant from the sides of the triangle. So that distance right there is going to be the same as that distance right there, the same as that one right there. All right? Now when I say the distance from a point to a line, it's got to be perpendicular. This is very important. Okay, now I made them different colors because this line doesn't go all the way through, right? If I went all the way through, it would hit right here, wouldn't it? If this went all the way through, it would hit right here. If this one went all the way through, it would hit right there. So they only intersect right here. The distance, these red lines right here, this one, and this one are all equal to each other. Everybody got that? Okay. Now, let's put some stuff in here, and let's try to solve these problems. So that's D. The incenter itself is H. This point is F, and this point is G. All right? Let's put some numbers in here. They say that this length right there is 25. They said that this one is 24. This angle down here is 30 degrees. It's kind of ugly, but it's 30 degrees. This length right here is 11. And this angle right here is 28 degrees. Everybody with me? That's everything they give you. They give you a ton of stuff. Sure hope you guys are paying attention and hope that helps you on the test tomorrow. Is it? Somehow I don't think it is. Let's pay attention up here. So what are we trying to find? Look at angle 10. We're trying to find DH. Number 11, we're trying to find BD. Number 12, we're trying to find angle HAC. And then number 13, we're trying to find angle DHG. The angles are actually the easiest part of this. It's the sides are a little bit tough. So let's pay attention. This is not just a simple thing where you say, oh, that one's that, this one's this. It's not a matter of that. So let's take a look. I want to find DH. Where's DH? D is right here and right here. So let's find this. We'll call it side X. Is that all right? Just to give it a variable. So we're going to solve for X. Solve for that side right there. Well, we know it's a right angle here, don't we? Because if that's a right angle, that's a right angle. We know this side is 25 right here, but we don't know either one of these sides. But watch this. If this is 24, what do you think AD is going to be equal to? It's going to be 24. Now, there's reasons for it. If you want to see the reason, let's see, what would it be? It would be, oh, this is bisected, right? So look, I've got an angle, and I got AH, which is a side. So these two triangles are congruent to each other because of angle, angle, side. If they're congruent to each other, if this is 24, guess what this is? It's 24 as well. So look what we have. We got a nice little right triangle here. Let's I'm going to put this up on its side just to make it a little bit easier for us to see. See this triangle right here? All I did was take it and twist it. You got it? So that's this triangle right here. This length is 25. This length is X. That's what we're trying to solve for. What's this length right here then? 24. Now, we've talked about this before. We haven't used it a whole lot this year. We have another chapter on right triangles that we're going to use this a lot more. We haven't used it a lot. So I'm kind of surprised they put this on here. But it's something that you should have learned in Algebra 1. It's something that we have talked about this year. We haven't spent a ton of time on it, but we have talked a little bit about it. Do you remember what it is? Right triangle. If I know two sides, how do I find the third side? It's got a name. Yep, you got it. It's Pythagorean theorem. You remember that, don't you? You remember that before you came into this class, didn't you? Right? Before you came into geometry. So, what is it? It's a squared plus b squared equals c squared. What's my a and b here?
24,
So, no, it's not 24 and 25. That's the c. The c is always the hypotenuse. The a and the b have to be the two legs. It's the x and the... They got to be sides, not angles. It's the x and the 24. So watch. I go x squared plus 24 squared equals 25 squared. Who's got a calculator on them? Get it out. Quick. Quick. Get a calculator out. Need some help with some of this math. So watch what I'm going to do. First of all, I'm going to subtract a 24 squared from both sides. Because I want to subtract that from both sides. Let's see what I get. X squared. What's 25 squared? Just 25 squared.
250.
No. 625, right. And then what's 24 squared?
576.
Okay. Now when I take 625 minus 576, what do I get?
49.
Okay. And then how do I solve for x then?
Square.
Square, not square it. Square root. No, square root it. So what's the square root of 49?
7.
It's 7. So guess what this length is? It's 7. Alright, so you had to do Pythagorean theorem to find this. Alright, so DH is 7. What about BD? BD, from here to here. Now look, I got a right triangle here as well, don't I? Look what I have. Let's draw it a little straighter. Okay, watch. This side up top here is 7. This side is 11, isn't it? Right here. And we're trying to find DB, or BD, which is this right here. We'll call it Y. See how I just took this and tilted it a little bit? Is that all right? Okay. So look at this. Pythagorean theorem again. How are we going to set this up? A squared plus b squared equals c squared. What's my a and b?
7 squared.
Yeah, let's do the y first. Y squared plus 7 squared equals 11 squared. So watch. Y squared. Let's subtract a 7 squared from both sides. So 11 squared is 121. 7 squared is 49. What's that? What's 121 minus 49? Is it exactly 70? Yeah, that sounds right. 121. Yeah, I was going to say, yeah, it's got to have another number there. It can't be a 0, so 72. If you're not going to help, you can leave. All right. No, it looks like the way you're smiling, it looks like you just said that just to get me off track here. That's exactly what you did, I'm sure. Okay. So if you're going to help, help. But don't just throw out stuff, because this is not the first time you did today. Because before you were just yelling out stuff, and I know what you're doing. Okay? So watch. Can I take the square root of 72? Does that come out even? Connor, what'd you get for square root of 72?
8.485.
Okay, 8.48, which rounds to what? 8.5. And that's what our answer is right there. It's 8.5. So that's what DH is, and that's what BD is. See that? We haven't done Pythagorean theorem much at all this year, so you probably didn't even think about doing it. But now you've got right triangles, right? And you got two sides. If you have right triangle and you got two sides, you should be able to find the third side by Pythagorean theorem. You should be able to do that every single time. So there you go. Now, I don't know. I can't remember off the top of my head if you have one on the test where you have to do Pythagorean theorem. But it's not out of your realm of possibility of doing that. Let's do this. Let's do angle HAC. Let's find that. This is H, this is A, and this is C. So we're trying to find this angle right there. Everybody see that? Now we know this one and this one are equal to each other, but I don't know. Does that help us? I don't know. Where do we even start? I don't know any of these angles around here. I don't know any of these angles of these triangles, but I do know a couple angles down here, don't I? So I know this is 30. So let's do this. If I know this is 30, let's change colors. I don't know if you can even tell the difference between the colors or not, but watch. If this is 30 and this is 90, what's this angle right in here going to be?
60.
It's going to be 60. Do you see that? What's this one right here going to be? Well, remember, these were angle bisectors, weren't they? So those two are equal, and that's a 90-degree angle, so that's going to be 60. Okay? What about this one?
60.
You sure about that?
62.
62, right, because it's a 28 and a 90. 90 minus 28 is 62. So that's 62. This one right here,
62.
that's going to be 62. Let's find this one and this one. You could do it... I'm going to do it like we did the other class. I'm sure there might be an easier way, but I like to do it this way. Watch. Look at this big old angle right there. Let's find that big angle right there. All right, not just the individual ones just yet, just the whole big one. What if I added up all these angles? Those two, the 260s and the 262s. What would I get?
360.
360. Very good. Okay, so let's do this. Let's call this angle, I don't know, Z.
B.
Let's call it angle Z. All right, so if this is Z, watch, I got Z plus Z, which is 2Z, right? Plus what?
Plus 62.
62 and 62, which is what? 124 plus the 60 and the 60, which is 120. And what should they add all up to be?
360.
360. So let's do some math on this, see what we get. So 2Z, that's what? 244? So subtract 244 from both sides, and you get 116. And then you divide both sides by 2, and then Z is 58. Is that my final answer, though? Is that what angle HAC is? No, I already divided it by 2. I already took the 116 and divided it by 2. So that's 58, and that's 58. What are we trying to find, though?
DH.
We're trying to find this one right here, aren't we? We're trying to find this angle right up here.
I don't get that.
I know what it is.
You don't get what?
32.
Yeah.
You don't get what?
Did you already divide it already?
I already divided by 2 right here.
Alright.
See? 2Z equals 116. So these two add up to be 116. So I split them both in half. That's what I did right there. Okay? So how do we find this? Remember, this is 90 degrees. Go ahead, Connor.
This is the one. This is not 90.
Yep, this is 90.
90 minus 58.
Yep, 90 minus 58. So let's do that. 90 minus 58 is 32. So this angle right here is 32 degrees. And guess what? So is that one. But what we're trying to find this, right? So that's 32 degrees. Took a little extra work, didn't it? These are a little bit harder than what you're used to on your worksheets. But I think you can see what's going on here. One more. Angle DHG. Let's find it. DH, where's G? There. So it's this one. This is what we're trying to find. Now, all that stuff that we did earlier should help us out with this. If I want to find angle DHG, it's this whole angle from here to here. What was that? It's 120, right, because it's 60 and 60, right, which is 120. And there you go. You've got those two angles. Wow. That was a mess, wasn't it? All right? A lot of stuff you have to know. If you're not sure about that, you didn't catch a few things, I went a little fast, go back on YouTube tonight and look at it and take your time with it. Pause it, stop, think about it, write it down, okay, all that kind of stuff. That's a nice thing about having these things on YouTube. Like, it's a nice thing about having this stuff on YouTube is that if you don't quite get it, if I go a little quick, little fast in class, then you can always go back, stop it, slow it down, take all the time you need to figure out how to do these things. Okay, let's do a little bit more. The question says, which one's larger, which one's smaller? So we're taking a look at angle 1, taking a look at angle 5, and angle 6, and we're trying to compare those to each other. Look, I've got angle 1, which is an exterior angle, isn't it? See that? And now I'm going to compare it to 5 and 6. Well, look at this triangle. See this triangle right here that I'm going around? Well, this right here and this right here, now they're not equal to each other. I know they all have one arc on it, but they're not all equal to each other. But these two over here are what to this? Give me the name. Remote interior angles. Okay, so that means the exterior angle has to be bigger than what? Those two. Now look, I know angle 5, but angle 5 is just part of angle 3 plus 5, right? So if angle 1 is bigger than that whole combination of 3 and 5, it has to be bigger than angle 5, right? And it also has to be greater than 6. Why? Because angle 1 equals this whole angle plus this whole angle. So these two angles both have to be smaller than angle 1. So that means which one's the biggest one out of all these? Angle 1's got to be the biggest one. See that? Okay. Let's get rid of these arcs. And we keep the same picture. Let's do 3 more. Let's go 9, angle 8, and angle 3. Alright, let's take a look. Here's angle 9, here's angle 8, and here's angle 3. Which one do I look for first?
3.
I look for the... Yeah, I find the exterior angle. That's right. That's what I like to look for.
Because you did the same thing on the first one, right? So we'll start with 8.
Okay, let's look at this. Look at this. Look at that same triangle that we were talking about earlier. Everybody see this? So angle 8's got to be bigger than what? Angle 2. Well, that's not even one of my options, though, is it? But we do know it's bigger than angle 2. We also know it's bigger than what? Angle 3 and 5, right? So that must mean it has to be bigger than 3. So we know that 8's bigger than 3. You okay with that? Okay. How do you know it's bigger than 9? Yeah, because angle 9 is a right angle, but...
And number 8 is not pretty big.
Yeah, but you don't know it's... I mean, remember, we can't always go by that. Let's...
I know how.
Go ahead.
Because number 9 is like the same as number 7.
Right, there you go.
8 has to be bigger than
Exactly right. 7 and 9 are exactly the same, aren't they? Because they're all right angles. So that's a right angle as well. So look, this is a remote interior angle to this. So 8 has to be bigger than this. So if 8's bigger than 7, 8 has to be bigger than 9. So guess which one's the biggest one?
8.
Angle 8. Okay. You see that? Let's do a couple more. 4, angle 3, and angle 2. Alright, so let's get rid of these arcs. You guys watching? Paying attention? Some of you guys have your heads down. Not a good position to be in. Jamie, wake Isaiah up, please. Isaiah, get your head up, please. Sit up straight. Sit up straight. Get your head off the desk. Sit up straight. Back straight. You know what sit up straight means. Come on. I got 4, 3, and 2. So look, here's angle 2. Here's angle 4. Now we know that's a right angle. And we're looking at angle 3, aren't we? So let's do this. We have no exterior angle on this, so we can't go by the same kind of information we had before. But look, I know this is a right angle. I know this is a triangle right here, right? So a right angle always has to be the biggest angle in a triangle, in a right triangle. Okay, so if I have a right triangle, the right angle always has to be bigger than either one of these. Because angle 2 and angle 3 do what? They add up to be 90 degrees, right? So 90 has to be bigger than 2, and 90 has to be bigger than angle 3. So this has to be the biggest angle. Which one is this here? It's angle 4, and there it is. So angle 4 has got to be the biggest angle. Yep. All right, does that make sense to you? All right. What are some other things? Make sure you look at that chart about circumcenter, incenter, what was the other one? Centroid, orthocenter. You got to look at that stuff. I'm telling you, if you just walk out of here, out of this class, and say, we just have a test tomorrow. You're sitting in your locker. You ever do this? The people next to your locker have the same class. What do we have for math? What do we have for history? What do we have for English? Don't do this. Don't stand next to somebody in your locker and say, what do we have for math? Oh, nothing. There's just a test tomorrow. All right? Because it's not nothing. All right? It's studying. Make sure you go through that. At least, at the very, very least, study that chart on page 337. All right? You're going to need to know the difference between those things. Okay? Make sure that you know those things.
Is it just going to be questions like this the whole test?
It'll be similar to this. I mean, we didn't do an inclusive review. I didn't hit every single type of problem that's going to be on the test. Okay, are some of these kind of problems going to be on the test? Absolutely. There may be some other ones. We might have hit a couple things here that may not be on the test, all right? But, yes, it is. All right, so anyway, so make sure that you do study that. That's very important. Okay? All right, it's up to you now to study for this. The test is tomorrow, and be ready for it. Don't just blow this thing off.